So hello, I'm Dmitry, and I'm not going to do a long introduction. So I've been using Kotlin for the last few years, so I'm like a Kotlin developer, I guess. And I also assume that you are familiar with Kotlin, so I'm not going to explain lots of details in this talk. And just to start with the idea of server as a function, it doesn't really come from http4k. Probably one of the sources for it to be popularized was this paper, Your Server as a Function by Marius Eriksson, which describes their experience building Finagle and using it at Twitter. So http4k, to be clear, it's a library for creating HTTP clients and servers. It's similar to Kotlin in a way, takes ideas from different areas and combines them in a nice and pragmatic way. And for example, for Finagle, they take Finagle is protocol agnostic, and as you can guess, HTTP is focused on http4k is focused on HTTP. And that was the homepage. It's an open source project, Apache 2 license. It's all written in Kotlin. That's the homepage on GitHub. If we look at the history on GitHub, you can see it started somewhere in 2017, and there are two main contributors, David Denton and Ivan Sanchez. And I'm not going to go to explain a lot of details about http4k in slides, so instead I'll just do some coding. And to pick a problem, I'll do tic-tac-toe or noughts and crosses, which is like a small game, 3x3. To be clear, I'm going to do it in a way that kind of simulates a paper. It's not AI or anything like that. So that's the architecture I'll try to do. So there will be front end and back end. So from browser, we do get request to front end, then which forwards it to get output to back end. Back end sends the back JSON and then HTML. And I'll do it in IntelliJ and obviously Kotlin. So now I'll switch to IntelliJ. So this is IntelliJ in presentation mode. And to start with, let's just write maybe hello world in http4k. So in http4k, one of the main abstractions is HTTP handler, which has type of HTTP handler. And it is basically a function which takes a request and returns a response. So in this case, HTTP handler, we can just go to source code and see it's request to response, just type alias. And here we want maybe some body, and we want to say hello world. And this is just a function, so we need to actually start a service as a server. So we can call this function as a server and just plug in Apache server here. And we want to port something like 1234, and we want to start it up. So what happens here is that Apache server is part of http4k, but it just wraps this function in actual server. So it started, and we can now go to, let's say, terminal and run curl, and you can see that curl did get request here and got back 200 with hello. So that's the thing. So that was using it from curl, so we can do the same thing but from http4k itself. So we can do HTTP client, which is also HTTP handler, and here I'll just use OKHTTP, which is a library. It also just plugs in into http4k. And we can do HTTP client and do a get request and just go to the same address basically. 1234, and we get back a response, which we can print. So what's going on here is basically the same thing we saw from command line. So now we get back hello again, but this time it's done from Kotlin. The interesting thing here is that both server and client, they have exactly the same type signature. So they're both handlers. They get the same request, and they get the same response object. So it's identical type signature, which kind of makes sense because client represents server remotely. So this is a little bit like funny server because it just always says hello. Maybe we want some routing. And for this in http4k, you can just do routes and say /hello. Hello. And then we can say bind get to, and the same code we had before. So to be clear, all this bind gets not really DSL, just a bunch of functions, and routes returns another HTTP handler. So it's just functions. So it now says 404, obviously. So if we do hello here, it will do hello world. So yeah, so another thing which we don't use here is request. So yeah, it worked. And then we could maybe replace world with name, and just name will be something we take from request. And the way we can do it, just get a function called query and extract name. So I'll do remove this and pass in name here as an argument to say it will Bob. If we run this, it should say hello Bob. If I didn't mention request and response are immutable, so it's kind of functional programming, so it's quite nice that they are immutable. Now it says like, hello Bob. The problem here is that if we don't have any name, the query function returns a nullable thing, so we could try and maybe throw an error if we like really want to have something. So if we do this, then obviously this line will error is a function in Kotlin which throws an exception, and we don't catch it here. So we still though have 500 back, and it's kind of server didn't crash. This is because Apache server itself is doing error handling, but we could do kind of better and do this handling ourselves. So for this, there is another concept http4k which is called filter. So let's write like catch all filter. Yeah. And filter, if we go to the source code, it's basically a function which takes a handler and returns a handler. So it kind of wraps them. So the simplest filter we can write is just filter. It takes a handler and just returns it, so it does nothing. Then, since we want to do something, we need to write wrapper handler, and it will be also HTTP handler. And it takes also a request, and then it calls next handler and passes request in, and then we just return wrapper handler. Again, it's still not doing anything, but now we can do like this try catch basically. And when we catch an exception, let's just like swallow the whole thing and return some response for fun. Let's return I'm a teapot. And then we just need to plug this into the server as a function. By plug, I mean it's just functional composition. There is no framework thing, nothing like that. It's just function calling another function. Now we get I'm a teapot back. There are built-in filters in http4k. For example, there are debugging filters, and there is print request and response filter, which we can then maybe compose with our catch-all, and then this will be filters, like multiple filters. Although again, it's just functional composition, so it's just type is just filter. So we can do all filters, and then we have our app as a function, basically. Also, catch-all filter, there is built-in one. It's not exactly the same, but it's probably a better idea to use it instead of what we had. So I'll delete this code. So that's basically advanced hello world in http4k. So to actually do nuts and crosses, we probably don't need this thing, like we don't need the client right now, and we want to extract roots into a function. So let's call it game backend. So game backend can be just a handler, and that's what it really means, just that our whole server will be just a function, right? And then also handler is used once, can like that. And let's maybe write a test for this. So I'll switch to tests and write class called game backend tests. And what we want from the game is the simplest thing, get game state probably. And what we want here is a backend. Let's create it as a field in the test. And then we can call backend and get, let's say just /game, and we'll expect something like a result OK, which I'll just define as an extension function on the response. And so as a status basically should equal OK, where should equal is just some assertion library, and this whole thing will return back a response, and so we can have it as a variable here. And from response we can extract body string, which should equal some JSON, like some game JSON. It's not clear right now what it is. So if we switch back to main function, well, we can run this test in the first place. Right, we can run this test, it should fail. And with 404, because we don't even have game in the main, so that's what happens. It's expected 200. So we need a game, then we don't really need name here, don't need request. And what we want here, we want something like a game, which we don't have. And we could probably write some tests to test drive the game, but it's not the focus of the talk, so I'll just type what I kind of had in mind anyway. So we could represent game as a data class which contains a list of moves. And move will also be an immutable object which has like x and y coordinates plus a player. So in a way it's a bit like event-driven design, I guess. and player is just an enum of x and not. So yeah, that's the idea. Also by default there will be no moves after we construct the game. Yeah, and here we want some output. So if I run the test again, I don't really expect this to work, but just to see that the game was plugged in and something is happening. So now we can see that test expected some JSON, but got game to string. So at this point, what we could do, we could just use some object mapper to JSON, for example, but more http4k thing would be, like more idiomatic way, would be to use lenses, which is functional programming concept. I'll explain it a little bit, but not too much. So the syntax for it in http4k to say body auto game and then to lens. Then we'll need an import for this, like this, which is Jackson. So basically, lens is an object which has like an interface which has two functions, inject and extract. So in this case, we want to, game lens. We want to inject it. So there is inject and extract. So it knows how to inject a game into a response. So basically, in this case, lens will combine will serialize game into JSON and put it into response, and it just knows how to do it. And there will be another side when it can extract it from a response and deserialize. So in this case, now it makes more sense. So there is expected some JSON, but it was an actual JSON. So I think I'll just put it back in the test and just run it. So this should pass now. Yeah, it's a bit more complicated. So basically, I'm not going to explain lenses, just look it up. But in http4k, it's part of the library, it's easy to use. So maybe the next thing we could do is just get the game in the state, and again, to test drive the next behavior, we can say players make moves. And what we want, something like maybe use put and say game, and x will be equals to 1 and y will be equals to 0, and player will be determined by the game itself. So it will know whose turn it is, and maybe one more move with 2 and 0, maybe swap these ones, so 0, 1, 2, 0. And then we, at the end, the idea is that we do 2 requests to the backend, and then it will change its state, and when we request its new state of the game, it will be again something else, some other JSON. So if we run this, it should fail because right now we don't have put handler. So it fails again on this line because in the main function we only have binding for the game get, not game put. So we need something like that. And then we want to extract x and y from the request. So the simple thing would be to do it like we did before pretty much with hello world, say this and query x convert to int, and this will be x of type int, or int question mark. But there is, again, we could just use lenses. So we could define a lens. This time it will be not a body lens, but query lens, and we can say it's required, it's called x, and the same for y. So here we can replace it with not exactly equivalent, but similar code. And this time we use lens to extract a value. So we extract x and y from the request. And so we have ints. Then with this ints, what we want something like make a move in the game. So should probably extract this as a parameter into function. So now like backend takes game as an argument, it's a bit more testable and configurable. So we want something like game.move, and this, because game is immutable, we'll just maintain it as a variable here, and we'll need to have initial game. So rename the argument to initial game. So what happens here every time you put it, we extract x and y. This move will return new instance of the game, and we update reference. So for move, we can just create a function which looks something like that. And at this point, we kind of, if we look back at tests, so we testing everything through HTTP layer, which is maybe not the best thing to do. At this point, I would definitely go and like write more tests for, say, class game tests, and do maybe a similar test, player makes moves, to make sure we have kind of domain logic, but just to save some time, I'm not doing it. And I'll just like do it the way I think it can be done. It's not very complicated. So what we want to make a move, it should definitely return a game, so we'll just copy with moves, and then it will be existing moves plus a new move at X and Y plus the next player basically. And player, it will be if last player in moves, so we can say last or null. If this player was, let's say, player X, then we switch to not, otherwise we go with X. And that's how we can switch. We also might want something like winner to know who has won the game when the game is finished. We can call it find winner function. And for finding winner, we can go player.values and basically find player. Here we'll need to iterate, let's say, from 0 to, so let's go player wins if all cells in the row are filled by this player. So what it means, we can say moves contains a move with current X coordinate, and 0, this is the first row, and the current player. So that's the first row. It's not the best code, but it will do for now. So that's 3 rows. Then we can want to do like all the columns. And then that's main diagonal and the other diagonal. So that should probably work. So yeah, and that's like the domain. So if I run this now, we should get back some other JSON. So obviously there should be separate tests for the game itself, for this logic. So now we get, like the first test we wrote is already failing because it was a little bit like approval testing anyway, so let's just update this JSON. For the second test, the JSON becomes quite long, so I could definitely just, it looks right, in the first place it looks okay, but it's quite long. So there is another option which we could use, is just use a game length in our test. So instead of asserting on strings, we could say use the length, and then we expect back a game which contains move of 0, 1 and player X. And then we expect this to be 2, 0 and not. And so that should pass. So there is no like right way to do it, I think, because sometimes you want to eyeball your JSON, make sure your JSON is okay and kind of lock it down. But it also, if it's something more complicated happens, it's better to test like a domain level type of thing. So yeah, so that was basically backend functionality done. And it's not very visual, so maybe just move on to frontend, which will be just another function. So let's say we have game frontend, and it will take backend because it will need to talk to backend, and it will be just another HTTP handler. And it will probably look something, just sketch something out quickly. So it should also have roots for it in it, and maybe it will have like a root thing which returns response OK, and it will have body with some HTML. Like not clear, it will be something. Then we can plug it in into the main function. So we can say game frontend. And here it needs HTTP handler. So in reality, we could have just used this bit and use it like connected via memory, or we can just, for the sake of the exercise, just write backend client, which will connect via actual sockets to it. So it will be backend client. It will be OK HTTP again, but now it will also have a filter which will take base URI from the string we specify. So we can say base URI will be set from URI of, and this will be the URL of our service, so localhost 1234. So then we we can use relative paths when we talk to backend. And of course, this also needs to be kind of wrapped in an actual server and running on different ports. So that's how frontend starts up. And we can write one more test for it, probably like another set of tests for the front end. So what we want is game front end tests. and we want get game state again. And for front end, we in the first place need to create it. In our test, we now, like, I'll use it this way, just like instantiating everything. In reality, you can have an option how you want to do it. You could actually test it via HTTP to make sure it works over network. So for front end, also we want something quite simple. Let's say we do get the slash, we expect a K, and then we get back a response. And here I'll use, for verifying response, I'll use approval testing. I'll explain then a bit in a second. So here we need to say extend with and say approval test class, which is also part of http4k. And with this extension, we can have approver in our tests. It doesn't really matter exactly like how it works. I'll show it in a second anyway. So now with the approver object, we can say assert approved response. And if I run all these tests now, what's going to happen is going to do get request to our front end. Front end will return response with some HTML, and approver will try and kind of see if it can approve it. And because there was no previously approved anything, it should say no approved content. And the way it works, it creates a file called like the whole test and test class and test function name .actual. So if we open it, it says some HTML. And if we rename it to .actual, I'll use some shortcut for a plugin, so it becomes .approved. And now if I run the test again, it will just pass because we approved the content. So basically by just renaming the file. And so yeah, it should all work. And yeah, it did pass. And then like finally should plug in some UI. So for this, there are multiple options. They could use Kotlin X. There is also templating framework handlebars. Somewhere, for some reason, IntelliJ has been slow. Wow. Not sure why. Yeah, handlebar templates. Then do hot reload, which is really just for development, and this will be our renderer. And so instead of HTML, we will just render something. And just http4k wants a tagging interface called view model, so we'll make it into game view. So just create an empty class for now. And let's say it with a class called game view, which will implement view model. And based on the class name, the renderer will look for a file with handlebars template called game view HBS for handlebars. So I'll cheat here a little bit and just paste some HTML in, which will work, and you can say like hello, more fancy things. And so if we run the test now, obviously this handlebar renderer should pick up the template and just render it, and approval test should fail. So here, handlebars is not part of http4k, just http4k provides nice integration with it. So handlebars is something else. So now if we look at the diff, it says like expected some HTML, but got this. So looks like something we wanted, so I'll just run the approval. We can also try and just run the main function, because so far everything was just based on some tests. And it's nice once you have actual UI to like manually, visually confirm that the things happen that what you expect. So now it should be running somewhere. So yeah, looks reasonable. So in reality, though, what we want here to happen is we want to talk to backend. And our front end, when we want to render the game, we want to call backend, and we can do get and basically do game. So we really, this is a bit overcomplicated for what we're achieving here, but just to so we do a request to get the game, and once we get it back, we want to deserialize it, and it's quite convenient to use lens here. So we basically get game like this by asking front end, and then we can convert game to view, which will be similar which will be similar representation, but for the handlebars template basically. So we can create extension function on the game. Let's maybe move it up, and it should return a game view. So for the game view, I'll just type what we want basically, but it's really based on handlebar templates. So we want something like rows, probably, which will be a list of lists of cell views. Cell views. And cell view will be also value with x of int, value y of int, and the player as a string. String question mark because it might be empty. And then we also want a winner, which will be also a string with question mark. So now to construct all of this, what we can do, we can convert the game. So for constructing cells, let's just iterate through all coordinates. So this will be x, then there will be y. And here we want to return some cell view with x, y, and the player. Player might be empty if nobody made a move in this part of the game board. And so here we just go through all moves and find move for which x is equals to the current x and y is equals to the current y. And if there was one, we just take player name. Right. So this looks okay. And then we can have winner is also simple. It's just a winner and its name. And then, so basically we constructed the cell view and view. So let's put it on separate lines. And then now we need to update the template. So for template, I'll cheat again. I'm not going to type everything. So here what we're doing in the table is just normal handlebars thing. So we iterate through all rows, like these rows here. Then inside row, we iterate through each cell. If there is a player, we print player. Otherwise, we print out a link, which we need to implement again on the front end to make the move. And at the end, we just print if there was a winner. So that's the whole idea. So now if we run the tests, they should fail again because we changed the template and because of the approvals. And the next step would be probably to just implement a function like this. Players make moves to make sure Frontend can handle the href, the link, which we have here. So like finally tests are running. So if we look at the difference now, so that's what we expected before on the left, and now it's prints out the whole board as lots of links because there were no moves made. So I'll approve this again, and then to write one more test. It will be quite similar to the backend test. So on purpose, I'm like doing lots of similar things across backend and frontend. So it will be get, not put, and just for the sake of doing something different, it's called move, and coordinates are encoded as part of the path, not as an actual argument. And at the end, we want to again approve the content of what we get in the front end. So I can line this. So basically, we make two moves, the same coordinates as the backend 0, 1, 2, 0, and then we request the front page, and we'll see what happens. So if I run this, it should fail because there is nothing. There are no approvals. So this is really the last thing we need to add for the game to work. So what we want here, we want a new endpoint called move, and to extract things from the path, that's a convention http4k. You can do this. There are other libraries which can do more typed-based path extraction and paths in general. So the previous tests are running. For some reason it's taking slow now, maybe because of projector. So yeah, the approval, it failed because there was no endpoint for move. So now there is. And if we do it here, we want to extract x and y from the request again. So and to do this, to extract it from the path, there is a function called path, so we can do something like that. That will be x. And then similar thing with y. And in this case, we just want to tell backend to do put on the backend. It's obviously not the best way, and also there is no error handling just for simplicity. So basically we tell backend make this move, and then we want, in this case, basically re-render the page. And to do this, the simplest thing might be just to return a different status, see other, and have a header, say location / so it's basically forwarding from here into here. So it's equivalent. To make test work though, we need to have this front-end handler wrap add a filter which to tell it to follow redirect, because by default http4k is not doing anything super clever, so it will just say, oh, you expected OK here, but I saw another status. It does like the minimal work unless you tell it to not to. And so basically this will run approvals. I'm not gonna wait for it because I think it should be right. And it might be easier just to take a quick look anyway how it works. So I'll try and run main at the same time. So let's see if it works. No, it didn't. So did it run the test? Still running. So if we run test, it says there is nothing approved, but we can take a look at the file. So that's a new actual file. It looks reasonable because that's like we made 2 moves, and so 2 of those links are gone. So I'll approve the file. So now it should be 2 approved files. Let's run main again and see. Should run. So just to collapse and maybe do an overview. So yeah, it's the main. Maybe just because for some reason compiler is super slow. Just to take an overview, what we had main function that these like lenses which can be reused in tests on client server side. Then this whole bit was just the front end. So it's quite big. Then backend, and then we had our domain. So like all these 3 bits we just meshed in one file. And then there were similar things in tests. So if we collapse all the tests, there were front end tests, backend, and domain tests. And there is like quite a big overlap, which could be refactored because could be abstracted away, and then you could have like one interface to make moves, but you could make move through an actual UI, through backend, or directly to domain and test through all layers. So now hopefully this works. Now we can make moves. So yeah, it switches the play, which is good. If I get to X, like X wins. Slightly weird thing is that if you want to start a new game, you have to restart the server. So yeah, just to test the opposite case manually to make sure it actually works. So we can go let not wins. So just go wrong move. So yeah, this also works. So moving back to like few slides left, there are more things in http4k. So there are more filters, in particular filters for tracing, like for Zipkin traces or recording and replaying traffic. So if you talk to external system, you can record how it behaves and then replay for your contract tests. There are integration with other Java libraries for HTTP clients, for HTTP servers. You can write Jetty and other servers. Has integration with other JSON XML libraries and template engines. So as a summary, these are like very simple main abstractions. There is HTTP handler, which gets an immutable request and returns an immutable response. And around it is like wrapped in filters, and there are lenses. So the main design goal, keep it simple. Yeah. Basically everything you've seen is just a functions calling functions. Then test everything to all layers, libraries better than frameworks. And what you can do now, if you're interested, you can type http4k Kotlin conf in YouTube, and this will be the talk by David and Ivan at Kotlin conf. It's quite good. Then obviously go to the website. There are cookbooks and tutorials. And on Kotlin links, like there is http4k channel. People are friendly there. Do that. And everything I showed, all the code and links I mentioned, they're all on GitHub. I'll tweet it. So this is the end. Thank you for watching.